Okay, hello everyone. Our today's lecture is about the engine terminologies. Now, what are the different engine terminologies? The first terminology is the engine bore. Now, what is the engine bore? Bore is nothing but it is the diameter of the engine cylinder. The diameter of the engine cylinder is termed as the bore. And what is the engine cylinder? Engine cylinder is that component of the engine in which four strokes, that is the suction stroke, compression stroke, power stroke, and exhaust stroke taking place. And the diameter of such a engine cylinder is termed as the bore. Now, stroke. Now, what is the stroke? Stroke is nothing but the linear distance traveled by the engine piston from top dead center to the bottom dead center. That is the distance traveled by the piston from TDC to the BDC is called as the stroke of that engine. Now, next is the stroke bore ratio. Now, what is the stroke bore ratio? It is nothing but it is the ratio of engine stroke to the engine bore. The ratio of length of engine stroke and diameter of bore of the cylinder is called as the stroke bore ratio. Engine stroke is denoted by capital L and engine bore diameter is denoted by capital D, and this stroke bore ratio is given as the ratio of L by D. Generally, the stroke bore ratio varies from 1 to 1.45. This is the general range of the stroke bore ratio. And as it is the ratio, so it is dimensionless. As it is the ratio, so it is dimensionless. General range of the stroke bore ratio is 1 to 1.45. And for tractor engines, stroke bore ratio, the general value of the stroke bore ratio is 1.25. For tractor engines, the value of stroke bore ratio is generally found as 1.25. Now, next terminology is the swept volume. Now, what is the swept volume? Swept volume is the volume displaced by one stroke of the piston, where capital A is the cross-sectional area of the piston and capital is the length of the engine stroke. What is the swept volume? Swept volume is the swept volume is given as the product of capital A into capital L, where capital A is nothing but the cross-sectional area of the engine piston and capital L is the stroke length. Capital L is the stroke length. Here in diagram, here you can see this is the TDC. TDC means top dead center, and then this level is the BDC, that is the bottom dead center. Now, what is the stroke? Stroke is nothing but the distance traveled by the piston from the BDC to the TDC. This much length is called as the stroke. This much length is called as the stroke. When the piston moves from BDC to the TDC, that time it travels the distance of one stroke. That time piston travels the distance of one stroke. And what is the bore? Bore is nothing but the diameter of the engine cylinder. Bore is nothing but the diameter of the engine cylinder. Now, what is the swept volume? Now, what is the swept volume? Swept volume is nothing but the volume displaced by the engine piston, volume displaced by the engine pistons while traveling from BDC to TDC. The volume displaced by the engine piston while traveling from BDC to the TDC. That volume is called as the swept volume. That volume is called as the swept volume. And total cylinder volume is, that is the top, this upper edge, from this upper edge to the up to the BDC. That much volume of the cylinder is the total cylinder volume. Then the volume between BDC to TDC, the volume between BDC to TDC is called as the swept volume. That much volume is called as the swept volume. And the volume between TDC to the upper edge of the engine cylinder, right? This is the upper edge of the engine cylinder. The volume between upper edge to the TDC of the engine is called as the clearance volume. That volume is called as the clearance volume. Then compression ratio. Next is the compression ratio. Now, it is the ratio of volume of cylinder at the beginning of the compression stroke to that at the end of the compression stroke. That is the ratio of total cylinder volume to the clearance volume. What is the compression ratio? Compression ratio, shortly, it is nothing but it is the ratio of total cylinder volume to the clearance volume. Means what? By diagram, it is nothing but it is the ratio of this much total cylinder volume, this much total cylinder volume, to divided by the only clearance volume, right? Means only that much volume, means it is the ratio of total cylinder volume. This is the total cylinder volume, and it is divided by the only this clearance volume, right? Only this clearance volume. This ratio is the compression ratio, right? Here you can see ratio of the total cylinder volume to the clearance volume is called as the compression ratio. Now, the compression ratio for a diesel engine varies from 14:1 to 22:1. For diesel engine, it ranges from 14:1 to the 22:1. And that is for the petrol type engine or the carburetor type engine, or also that is called as the spark ignition engine. The compression ratio varies from 4:1 to the 8:1. 4:1 to the 8:1. Now engine power. The power is nothing but it is the rate of doing work. Power is nothing but the rate of doing work, and SI unit of power is watt. SI unit of power is watt, and 1 watt is equal to the joule per second. Means 1 joule work done per second is nothing but the 1 watt power. If a machine does 1 joule work within 1 second, then that power of the machine is the 1 watt. And this is the conversion between joule and calorie. 1 calorie is equal to 4.2 joules. This is the conversion factor. There is also one unit of the power is the HP, that is the horsepower. And 1 horsepower is equal to the 746 watts. 1 horsepower is equal to the 746 watt. Watt and HP both are the units of power. Now, indicated horsepower. Now, what is the indicated horsepower? That is it is the power generated in the engine cylinder. The power generated in the engine cylinder and received by the piston. It is the power developed in the cylinder without accounting any frictional losses. that power is called as the indicated horsepower. Means what? What is the indicated horsepower? Indicated horsepower is the actual power which is developed in the engine cylinder. The actual power developed within the engine cylinder by combustion of the fuel, and the power which is received by the piston, in engine cylinder after the combustion of the fuel, or during the power stroke, Then indicated horsepower is computed by using the equation, that is the IHP is equal to P capital A into N divided by 4500 into small n divided by 2. Now here IHP is nothing but the indicated horsepower. It is the indicated horsepower. And here P is the power pressure applied over the piston, engine piston, given in kg per centimeter square. Then capital L is the stroke length, given in meter. Then capital A is the cross-sectional area of the piston, in centimeter square. Then capital N is the revolution of the engine revolution speed, that is, it is given in the RPM. That is the revolutions per minute. And small n is nothing but the number of cylinders. This formula is for four-stroke cycle engine, and that is for two-stroke cycle engine. The formula for two-stroke cycle engine, that is the formula of indicated horsepower, is given as IHP is equal to capital P into capital L into capital A into small n, where again P is the pressure given in kg per centimeter square. Then capital L is the stroke length given in meter. Then capital A is the cross-sectional area of the piston given in centimeter square. Then capital N is the revolution speed of the engine, that is the engine RPMs, that is the revolution per minute. Here these terminologies are given. Here you can see P is the mean effective pressure in kg per centimeter square, capital L stroke length, A is the cross-sectional area of the piston, then N is the revolution speed of the engine given in RPM, and small n is the number of cylinders. Okay, thank you. This is about the engine terminologies.